Hi, my name is Crystal Anderson. I'm an attorney at Frankly Legal, and this is my deep learning final project pitch on AI legislation and governance, or more specifically, the deep learning method of counterfactual fairness testing for developers. So, AI systems are increasingly affecting high impact and highly regulated areas like employment, income, credit, and housing. And in the United States, there's no single AI law telling developers exactly how to build or evaluate their systems to comply with the already existing regulations. Instead, AI governance is happening through civil rights law, state regulations, procurement rules, and largely litigation after the fact. Since there is no strong standard, developers are increasingly being judged not just on the outcome of their model, but whether they can show they used reasonable care in how their models were designed and tested. This creates a technical problem. How can developers provide audit-ready evidence to demonstrate responsible AI development? And here we propose a method that is reproducible, legally intuitive, and is a pre-deployment method so that developers can cover that risk and pass on misuse to the deployers. So the method here is counterfactual fairness sensitivity testing. Technically, the method is simple. You train your model, you identify a protected attribute in your data set you're running through it, like sex. You create counterfactual input sets where only that attribute is changed, and then you measure whether and how the model's predictions change. This is especially helpful when we are doing testing for discrimination issues. So here I implemented this method end to end using a neural network trained on the UCI adult census income data set. I used a very simple neural network and I did my best to include as much evidence as possible, right? Fixed random seeds for reproducibility, train test split for audit integrity, everything documented, all my results logged, visualizations and reports to log the performance metrics so that, we're having that evidence of reasonable care. Then I took the counterfactual construction, just making two forms of the test data, one original and one with the sex flipped. Then, use that to measure the model's sensitivity with the flip rate and the average probability change. I was able to create a visualization. My model did fairly well on not being discriminatory, and also created a report output that can be attached to model cards or shared with customers, or used in litigation defense to show that reasonable effort to make sure the model is not biased. So why does this matter for governance? Because US AI law relies on evidence. Courts and regulators will ask, did you test for discrimination risk? Can you document what you did? Can you explain the model behavior in legally intuitive terms? And counterfactual fairness testing mirrors the core intuition of discrimination law. Would the outcome have been different while producing reproducible, auditable metrics? And gives you some safeguards. There's many pros and cons. It's definitely not a method that can be used alone to say, look, I did counterfactual sensitivity testing and that's all, and everything is good. But with additional modeling and mitigation experiments, you can really put forward a more defensible model. So the key takeaway is in the US, AI developers are governed less by what statutes say and more by what they can demonstrate. And counterfactual fairness testing is one tool that helps turn deep learning evaluation into defensible governance evidence. Thank you so much.